Hello all, welcome back to my channel. If you understanding previous video, then please don't forget to subscribe. In this video we are going to solve mathematical induction problems based on summations. Okay, question number 9. Let h1 equal to 1, h2 equal to 1 plus 1 by 2 and h3 equal to 1 plus 1 by 2 plus 1 by 3, so on hn equal to 1 plus 1 by 2 plus 1 by 3 till 1 by n. We have to prove what? Summation of I equal to 1 to n hi equal to n plus 1 hn minus n for all n greater than equal to 1 by mathematical induction. Okay. Basic step. We have to prove for h1 is true. Okay. Consider n equal to 1. h1 becomes, substitute n as 1, 1 plus 1 hn minus h1 minus 1. 1 plus 1 is 2. h1 is 1 given in the question, minus 1. 2 minus 1 is 1. We can clearly see h1 is 1, and also in this series we can see 1. Hence s1 is true. Next step is induction step. In this step we have to prove this equation holds for all n k. Here is 1 by n. It is true for 1 plus 1 divided by n plus 1 and so on. To prove that, first consider this equation as s of n. It is true for some k greater than equal to 1. Okay. First write what is s of k. It is nothing but I1 k hi. Don't replace I by k. Okay. Wherever n is present, replace by k. hk minus 1 is true for k greater than equal to 1. Okay. Now we have to prove what? S of k plus 1 is also true. We assumed that s of k is true. Okay. Next we have to prove s of k plus 1 is also true. Is h of I equal to 1. Wherever k is present, put k plus 1. hi k plus 1 plus 1. h of k plus 1. Okay, here n I write here. What we have to write? hk minus k plus 1. This becomes summation I equal to 1 k plus 1 hi k plus 2 h of k plus 1 minus k plus 1. This is the equation we have to prove. Let's take this left hand side of this equation. LHS becomes summation I equal to 1 k plus 1 hi. We know that h of I equal to 1 to k plus 1. Let's break this and write in separate. That is hi equal to 1 k to h k. Wherever I is present, k put k. What is the next term? To write the next term, replace I by k plus 1. Okay. Hence the equation becomes h of k plus 1. We just replaced I by k plus 1, which is the next term. And we divided this equation summation part h of I equal to 1 to k. Okay. That is nothing but h of k. Plus the next term is h of k plus 1. Take this sum star. Okay, what is this h of I? 1 to k, h of k. That is nothing but k plus 1 into h of k minus k from star plus h of k plus 1. Now k plus 1, we have to find what is h of k. Okay. when we need to find h of k, first write the formula for h of k plus 1 by seeing this equation. We know that h of k plus 1 is here n. Okay, consider h of 3. It is the k plus 1th term of h of 2. That is 1 by the given equation we can say till 1 by k plus 1 by k plus 1 till this. Okay, what is this? H of k plus 1 by k plus 1 is h of k plus 1. We need what? H of k, that is h of k plus 1 minus 1 by k plus 1. This is the thing you have to know. H of k becomes h of k plus 1 minus 1 by k plus 1 minus k plus h of k plus 1. Multiply this k plus 1 into h of k plus 1. Multiply this minus k plus 1 into plus into minus minus, that is we can cancel k plus 1, remaining is minus 1. Then here minus k plus h of k plus 1. What is the common term? H of k plus 1. Take this out. H of k plus 1, remaining is k plus 1. First write it together. H of k plus 1 minus term, write separately minus term and the positive term. Now take h of k plus 1 out. H of k plus 1 out. Remaining is k plus 1, here common is plus 1, minus k plus 1. Here take h of k plus 1 out, remaining is k plus 1 and here remaining is 1, minus k plus 1. That is h of k plus 1, k plus 2 minus k plus 1, which is right hand side. Hence we have proved that s of k plus 1 is also true for some k greater than equal to 1. Similar to the previous, the 10th question, let hn defined as hn equal to 1 plus 1 by 2 till 1 by n. Prove the equation for all n greater than equal to 1. Okay, let's consider this equation as a s of n. In the basic step, what we need to prove? The initial condition is true. Put 1 here. 1 plus 1, 1 by 2, h of 1 plus 1 minus 1 plus 1, 1 by 4. That is 1 plus 1 is 2 by 2, h of 2 minus 2 by 4. 1 times h2 minus 1 by 2. What is h2? This is h1, this is h2. h2 is 1 into 1 by 2 minus 1 by 2. 1 and half minus half is 1. We can say S1 is true. The next step is induction step. In this step, what we have to do? We have to prove for s of k plus 1 is also true. Let take s of n is true for some k greater than equal to 1. And s of k becomes j equal to 1 k j h j, wherever n replaced by k, h of k plus 1 minus k plus 1 k by 4. Okay, now we have to prove what? S of k plus 1 summation j1 k replaced by k plus 1 j h j, k plus 1 is k plus 2, replace k plus 1 by 2, k plus 1 is k plus 2, minus replace k by k plus 1, k plus 2, this k by k plus 1. What we did? Replacing k by k plus 1. Okay. Next, this is what we have to prove. Take left hand side, that is summation j1 k plus 1 j h j. Okay. Now separate this summation terms, that is nothing but j equal to 1 till k j h j plus replace j by k plus 1, that is the next term. Okay, way of dividing this. This becomes k plus 1 h of k plus 1. This is the reason. Now give some star here. What is jhj? K plus 1 into k by 2 h of k plus 1 minus k plus 1 into k by 4. From where? From the star. Plus k plus 1 h of k plus 1. What we have to do next? So we have k plus 1 and h of k plus 1 is common. Okay, take this out. K plus 1 and h of k plus 1 is common. What is remaining? Here remaining is k by 2 and here remaining nothing. Separate the negative term, becomes k plus 1 into k by 4. That is k plus 1 h of k plus 1. Then here is k plus 2 by 2 minus k plus 1 k by 4. Now what should do next? Is there any common again? Yes, k plus 1 is common in these terms. Take outside, then it becomes k plus 2 by 2. Here h of k plus 1 minus k by 4. What to do next? We have to find what is k plus 1. As I said in the previous problem, there we have to find h of k. So from the formula we solved first h of k plus 1. Okay, here we have to find what? H of k plus 1. So first write the formula for h of k plus 2, that is 1 plus 1 by 2 plus 1 by k plus 1 till where? Till k plus 2 we want. This is h of k plus 2 till here is what? The last term is k plus 1 plus 1 by k plus 2. H of k plus 1 becomes k plus 1 h of k plus 2 minus 1 by k plus 2. This you have to note. Replace k plus 1, k plus 2 by 2, replace h k plus 1 as h of k plus 2 minus 1 by k plus 2 minus k by 4. Okay, next this is k plus 1 k plus 2 by 2, balance this equation, hk plus 2 into k plus 2 minus 1 divided by k plus 2 minus k by 4. K plus 2 common, Next k plus 1 remaining what? H of k plus 2 into k plus 2 minus 1 divide by here h of k plus 2. Here what term is left? 2 term is left, okay, and minus 1 is separate, minus k by 4 that equal to, make this minus 1 by moving to okay. Here I missed one more bracket, okay, h of minus 1, here is a bracket and here is a bracket. Now k plus 1 multiply with these terms and separate these terms, negative terms, and multiply by k plus 1, that is nothing but k plus 1 into k plus 2 h of k plus 2 by 2. First we multiplied with this term, next plus okay, k plus 1 minus 1 by 2 minus k by 4, okay, here plus. Now k plus 1, k plus 2, h of k plus 2 divide by 2, solve this, becomes 4 and this is minus 2 minus k, take the minus out and this becomes k plus 2, got it, k plus 1. So we solved this equation, k plus 1 here, k plus 2, k plus 1, h of k plus 2 by 2, h of k plus 2 minus k plus 1, k plus 2 by 4. That is the right side of the equation. Hence we can say s of k plus 1 is also true. Question number 11, and it is the last summation type problem. Prove by I to I equal to 2 plus n minus 1 into 2 to the power n plus 1 for all n greater than equal to 1. Let's take this as s of n, summation I equal to 1 to n I to I equal to 2 plus n minus 1 into 2 to the power n plus 1. Okay, in the basic step we have to prove initial condition equal to true, that is 1 to 1. Substitute 2 plus 1 minus 1, 2 to the power 1 plus 1, 2 plus 1 minus 1 0, 2 to the power 1 plus 2, multiply anything is 2. Whether the first condition is true? Yes. Hence we can say s of 1 is true. Okay. The next step is induction step. Consider s of k becomes summation I 1 to k I to I 2 plus k minus 1 2 to the power k plus 1. Okay, we have to prove what s of k plus 1 becomes summation I 1 k plus 1 I to I, wherever k replaced by k plus 1 minus 1, that is k only, into 2 to the power, replace k by k plus 1 plus 1, 2 to the power k plus 2. This is the thing we have to prove. First take summation I1 k plus 1 I to I, write this as summation I1 k I to I. What is the next term? Replace I by k plus 1, that is k plus 1 into 2 to the power k plus 1. till here. From the star we get what? 2 plus k minus 1, 2 to the power k plus 1 plus k plus 1 into 2 to the power k plus 1. Here 2 plus what common? 2 to the power k plus 1 is common. Remaining is k minus 1 plus k plus 1. That is 2 plus 2 to the power k plus 1 into 2k. 2 plus 2 to the power k plus 2 into remaining is k. Okay, this is right hand side. Hence we can say s of k plus 1 is also true. So if you understand something, then please like the video and subscribe to the channel. Thank you.